those of you who are watching, could someone tell me in the comments whether or not the voice is working? All right, good. All right, so let's do this, I guess. Yeah, I'll give it two more minutes. But this is going to be a much shorter version of what was originally supposed to happen today an hour ago. Spent about 45 minutes trying to figure out how to actually get this done, and then I'll try again tomorrow and basically do something similar, but probably with a few more demos. It's just me here, so I'm gonna have to like move the camera around as I go around the shop. Yeah, I figured that was you. So, welding. I've talked about it a little bit in class, and as I said, we'll get underway here. It's 2:59. He said 3. Seems to be like 1 or 2 people watching. I won't say your names because of like this thing called FERPA, and I don't want to get fired. So if you guys say it in the chat window thing, that's up to you, but I would recommend not. Alright, so, and close enough. So, for the 1 or 2 of you who did come back after the hour, again, sorry about that. Most of you probably think about welding involving something like this, just because that's what's readily available and everyone has these. This is a propane torch. It uses ambient air. Let me throw my safety glasses on. It uses ambient air and a propane fuel. The flame doesn't get as hot as you'd think. Off the top of my head, I can't remember the exact temperature, but you might be able to get something cherry red. You're not going to get it to the point where it actually is going to be able to be welded. And what welding is essentially the fusing of metal. And I'm going to switch my glasses here because it happens with at a certain temperature, and these things are awesome. They look horrible, but they are awesome. And it happens at certain temperatures for certain metals, depending on if it's aluminum, steel, stainless steel, etc. But what we're trying to do is get that metal to a temperature where it essentially becomes molten. And we can do that in a couple different ways. We can use flame. This is an acetylene torch. And what it does, a little bit too much, so still a little bit too much. Not enough. This one's a little finicky and I haven't checked the gauges. Flame like that, where we're using a fuel such as acetylene and an oxidizer like oxygen, what that's going to do, see it through the two different cameras we're using. What that's going to do is it's going to allow us to heat up the steel to the point where it becomes molten and allows us to fuse it. And that's really what welding is. And what I'll do tomorrow is I'll try to set up to do a demo on that. I'm set up to do a little bit of a blacksmithing demo right now. But the point is, and those of you who've had me in class, and those of you who have heard me talk about welding or anything involving tools, I always start our tool set. And that's kind of what we're doing today, is we're going to go over the tools of the trade, so to speak. And these are the tools I generally pack in my bag. I used to travel around to different job sites for a company that built gasification plants, and I used to work in a couple different shops. One building awnings in Middlebury called Duracell Awnings, and then a dock company called Dock Doctors in Ferrisburg. Both the two companies I started out with are both doing really well, and still around, doing some pretty cool stuff. But when I used to work on the road, or even most recently when I was doing a short-term stint with Duracell, this is my welding bag. I've had this for approaching 15 years, and normally it can weigh in about 50 pounds. And I've got a baseline set of tools. Let's get rid of this because that's not one of them. I've got a baseline set of tools that I normally carry with me, and there's a reason for that. Because if I have those, I pretty much can do 80% of the stuff I need, and a lot of it comes down to, this is cold now, which is really sad. I didn't build a fire in here, but I can lay out, I can build stuff, and I can cut, and then the rest of the stuff normally is on site. But my personal hand tool complement, I always carry a certain set of things. First off, it kind of seems funny to start with a power tool, but it's a grinder. The reason I keep a grinder with me is because it's kind of for prep work, for cleanup work, for fabrication, which is taking metal or materials and putting them into taking materials from raw material into a usable form. The grinder's kind of a great little deal because you can basically, this right now I've got a wire brush on it. That wire brush is used for basically cleanup, removing rust to a certain extent, and debris from other things and whatnot. But then you can also, as I said, you can use it, I'm going to put this down, with a grinding disc, which takes more material off, a cut-off wheel, which takes basically a thin strip off. You use it on the edge, whereas a grinding disc, yes, you can use it on the edge, but generally you'll find you'll use it on the flat. And then a flap disc or a sanding disc, there are a bunch of different iterations and versions of this in different grits, etc. But those things, and then other variations on the wire wheel. These things basically are a great way to get little shards of metal thrown at you. They're great functionally. When they get older, they sort of hurt a lot. Anyway, so that's like starting off the big thing. I'm going to breeze through, for those of you who've had me in class, most of you remember that this is a combination square. I always carry one of those. Little torpedo level. Speed squares in two sizes. Because the 6-inch is good for a lot of things, but then the 12-inch allows us to get larger pieces, and then when we're doing flat layout, and then a framing square. So basically like 6, 12, 24 inches of layout material. Then I carry a chalk line. And for those of you who don't know what a chalk line is, a chalk line essentially enables you to draw, without physically drawing, a straight line over. Never actually maxed one out because they start to wander the farther out you get. But they are great for straight lines on longer pieces, 6, 8, 10, 12 feet. As I said, they're not super accurate. You'll get about a 1/16 to an 1/8 variation, which is significant, but normally those pieces hopefully will be hidden somewhere. I also carry string, and string used with a chalk line, or because in a lot of ways they're the same. And a chalk, for those of you again who don't know what a chalk line is, you pull this thing out. I don't know if you can see that, but it's basically a piece of string dipped in chalk. And what you do is you hook it on one end of whatever you're measuring, and you pull it out, and then by holding it taut, it creates a straight line. You pick up on it just ever so slightly, and when you release it, it leaves that chalk on whatever piece of material you're trying to mark. All right, let's see here. So that's basically measuring. I normally carry 2 or 3 tape measures, sometimes as many as 4 with me. And it seems a little crazy, but I'll carry a 25, which I keep on my belt. These are both 25 inch. If I'm doing something that I'm going to be measuring a lot of longer stuff with, out over open space, I'll carry a tape measure like this, Fat Max, which is wider tape so I can get out farther. This guy is a 25 foot with a thinner blade. I'll use that for smaller layout stuff, and I'll carry a 30 footer as well. And if I'm doing something really big, I'll also carry a 100 footer. So those are the measuring tools I carry. Always have a couple different pairs of safety glasses. These are shade 5 safety glass. What that means is essentially that a shade 5, think about your sunglasses. I think those are about a 2 or a 3. I have to double check that, so don't quote me on it. But a 5 is much darker than your normal sunglasses, and it's for protection from this guy right here, the torch. So if you look at this thing when you're cutting or welding with it, you'll end up with a nice little white spot in your vision, which is never fun. I'm actually going to adjust the camera just a little bit. So hopefully that'll be a little bit better. Let's see. Yeah, maybe. Yeah. All right, so then the other stuff I carry, go just real quick. Pair of channel locks for grabbing stuff. A striker, obviously, for lighting torches. I'll carry two wrenches. These guys, this is a spud wrench. This is actually my favorite tool. You can align stuff with it. You can take bolts off with it. You can stab things with it. Normally, this is referred to, you can also get ones that aren't adjustable, but iron workers, guys who are putting up buildings, will use these. And the stabbing part, if you lose your footing, like sometimes you can grab something on the way down with that. Okay. As I said, I always carry second wrench of either similar or just one size smaller, because what that enables us to do is take bolts off, put them on. So, actual other welders' tools. Like this is like the stuff that I would carry. Some of the stuff I carry on me, a chipping hammer. I'll talk about that in a second, but that's for removing what we call slag, which is a buildup on welds when you're stick welding. A cold chisel. We talked about these in class. And a brush. Sometimes you'll find them that there are chipping hammers with brushes on them. I hate them because the brush always falls off. in my opinion, the ones I've had. I'll carry a couple different hammers. This guy is my general persuader. And I'll also have a like a little ball peen. File for prep work, cleanup. Center punch, which is used with the hammer. What you do is you lay something out, if you're going to put a hole in it. Excuse me. You use the center punch to basically put a little hole where you're going to drill through so the bit doesn't wander. Screwdriver, we've all seen these. This is an 11-in-1 just like we have at school. Pair of welding pliers, which I'll talk about a little bit later. These go with a specific welder. Little pair of channel locks, tin snips, which are for thin sheet metal. I got a couple different kinds of those. Some type of knife. And then we have all the weird stuff that I've acquired, not acquired, but this is basically a bunch of different marking stuff. I normally carry a pen, pencils, a couple different types of markers, depending on what I'm working on. This is a silver marker. It's better seen on darker stuff. Might be dirty. Black marker or Sharpie. And then this is called soapstone. It's basically the equivalent of pencil on steel. So that's basically what I carry in that bag. I know, as I said, I always start with tools, because tools are something that, like, if you can't afford like the welders, your basic hand tools are cheap. It's a good place to start. All right, so talked about basic hand tools yet again. So I'm going to move the cameras a little bit and talk to you about my welders, which I've got several. Maybe that's not going to work. All right. You see me okay on this? So, first welder here. We can't see. We're working on it. Actually, let's just do it from this standpoint. So first welder here that we've got is a Miller-Matic 250. I bought this guy, because I didn't buy it, it was given to me. Because it was going to go out in the trash. So, okay, you can see me, you can see the welder. Cool. Okay. This guy is what we call a wire feed welder. The way it works is in here there's a big spool of wire, and that big spool of wire there's a drive system in here that takes the wire and pulls it up, pushes it up through this lead right here. And what it does is, so you can see both me and it. All right, there we go. So what it does is this lead right here, that wire comes up through it, and I don't have it plugged in right now. What I'll do is if we do this again, I'll do a demo where I'm actually welding with this. Um, so basically what we're seeing right here is that wire comes through this lead right here. And let's see, maybe this will work a little bit better. Through this lead right here, and it basically creates a short circuit between the material you're welding and this piece, which this clamp will go on the whatever you're welding. And by virtue of that, it creates about a 7,000 degree puddle. And that's about 7,000 degree puddle. And that's what allows us to weld. Okay? So, looks like we're streaming a little bit. Uh-oh. All right, so we've got that. Hopefully you can still hear me. I'm not entirely sure. It said that things slowed down a little bit. But, so we've got this is what we call our ground. This is our MIG, this is called MIG welding. And what we're looking at, this machine right here, the newer versions, just to give you guys an idea. This guy, let's see. If you wanted to buy one of these, you could get one that's a homeowner version for about $300, $400, $500. Entry level. I recommend not spending any less than $1,000 on it. But this guy, the new version's about between $2,000 and $4,000, depending on what it is. So just giving you an idea. I'm not advocating for one brand or another. This is a Miller. I like Miller. I also like Lincoln stuff. And ESOP. Those are the three brands I've really used. There are some other really good brands that actually I've been talking with. I'd like to try their stuff out too. Like everyone's. I've never run into one of the major brands where there's an issue with what they have. So if you want to get into this, there are ways for you to get in, taking classes, hopefully with me in a few years, and then other places as well. So we talked about this guy. So this is my MIG welder. So I got a wheel I gotta fix. There's always something breaking. Okay, the other thing about MIG welding is that you see this bottle back here? This bottle is full of an argon, which is a noble gas, and CO2, which you're probably pretty familiar with as well. So argon, CO2, that's called weld mix. That weld mix actually allows us, let's put that up just a little bit more. Maybe, yeah. All right, so that weld mix allows us to keep an inert environment around our weld. So that's one. One other thing is that, again, always being safe. You always want to wear some type of flame-resistant jacket or sweatshirt or whatever to cover your arms, because we are dealing with really high temperatures. This is my welding hood. I always wear something over my head. And then this guy is what we call an auto darkening helmet. That auto dark helmet allows us to view whatever we're welding, and it's clear to begin with, and then as soon as I start welding it gets dark to protect my eyes. And then I have a couple different kinds of gloves here. I need to replace all the gloves I have because they're all at the end of their life cycle. But these gloves are a little bit thicker, and I use them generally for MIG welding and stick welding, which is what we're going to talk about next. Okay. So, next kind of welding we're going to talk about. This is my generator welder. I bought this probably about 2 or 3 years ago. This guy is, I'll show you. It's a generator. It's exactly what you'd think it would be. So what you do, choke. Not the best thing for it, but I want to show you. This is a motor driven. I'm not going to plug this in the wall. This is going to end up in my truck for me doing remote stuff when I am out in the field. I can run the MIG welder off this generator. There are also, just go up a little bit more with this or back or something. You can see both cameras, whatever. This guy is designed for harder use. This guy actually, I've seen it, this one in particular and other ones live out in the open on vehicles for their entire lives and they work great. So stick welding is different. So you saw the wire that we're using in the other welder. Stick welding is exactly this. This is a stick. This is what we call an electrode. It's got a metal core, which is what we use as what we call our filler metal, like the wire in the MIG welder. So there's a filler metal in here, and then it doesn't use a shielding gas like the MIG welder. It uses a flux. Essentially, flux is the wrong word because flux is different. But it uses a coating which actually covers the weld and keeps oxygen out. And the reason we want to keep oxygen out is because oxygen will cause what's called porosity. That little bit of porosity actually will cause the weld to be weaker. So, same concept. We have ground. We have a stinger. And by virtue of the work being grounded and the electrode being on the positive side, I know we really didn't talk about that too much, but the point is that it's very similar, but the skills needed are different, and then also the process itself is slightly tweaked, but the baseline welding is very similar across the board. I'm not going to talk about the third welder right now. I'll set up for either later in the week. So tomorrow at 2, we're going to do this again. I got one more thing I want to show you because I think we're at about a half hour now, and I don't want to go too much over that. So let's see. Yeah, we're at 28 minutes, so here's what we're going to do. I'm going to show you a little bit about blacksmithing, and then we'll call it a day. So this is my forging area in my shop. Eventually it'll be a little bit different, but so let me get that. Okay, so that should be good. So blacksmithing is kind of, as far as welding goes, you're not going to be able to hear me as well because I'm going to turn the forge on here. I built this forge about 10 years ago. It's a really rudimentary one. It's propane fired, and essentially what blacksmithing is it's kind of the lineage of welding. It's the start, but if you trace it all the way back, that's really where welding began. So it's manipulating metal even more so than welding is, in my opinion. But the two go hand in hand. So I'm going to start this up. This is going to be more of a watch what I'm doing. I'm not really going to make anything other than that I'm going to take this round rod and I'm going to square it off. Okay? So let's do that. As I said, so it's going to get a little louder in here. You'll be able to hear it. So I'm taking just a piece of paper towel. This is the safest way I could come up with to light this particular forge. Strike a match. Set the paper towel on fire. It's going to fly out the front. And here we go. So, let's see. Yeah, you can see it. So, basically what's happening is we've got the forge is running now, and it's basically burning the propane. There's an insulation in the forge itself, and that insulation allows us to contain the heat, and that heat is essentially focused into that metal, and what we'll see is it become red hot, and we'll go from there. So bear with me for a second. Putting some light gloves on, just to make sure that I don't burn myself. It shouldn't get too hot down towards the end. A lot of blacksmiths don't wear gloves for longer stuff, but I'm trying to show you what the best way to do it is. So you can see this piece, which I'm not going to work on, is changed color. You can tell heat based on the color. I don't have my exact temperature gauge because it's been a little bit of a while. So we're talking, this is probably, I can't remember off the top of my head, I apologize. But you can tell, I can touch it down here, don't touch it up here. That's basically the long and the short. Okay, so, red hot. I'll stand on the opposite side of the forge and stand on. So as I get it, it starts to curl up, and I actually start to see that there's an offset on the lower side. I think this is the camera to look at. You can see that. So what I want to do is keep it in the center. Flip it over, do the same, and I kind of keep it centered as I go. Can't remember which camera to look into. One of these will be right. Okay, so then what I do is I start to lose that really bright red that I had, so I'm going to send it back in the forge. Because I've got something else in there, it's going to still be active. One of the other things you can do while you're blacksmithing, multiple things. Like I might not want to change the overall shape of this, I just want to change the overall orientation. Okay? So, easier to bend. Also, because of its state, it's more relaxed. So I actually am not going to, you guys have seen what happens when something gets bent. It becomes brittle and can break. Okay, so back up to red hot. As I said, I want to square this off, so I'll switch. I go 180 degrees. And I'm rotating it 90 degrees at a time. Trying to keep it fairly centered. which one again. You can see that I've got a squared off piece that started, so just make sure I don't burn myself, round. So that's just a quick, turn that off. So it's just a quick kind of intro to my shop. We'll try again tomorrow. I'll do something similar, and then I can start doing other demos. See you later.